Hello, everyone, and welcome back to our Sky Tonight program. This is Seth Mayo again, curator of astronomy for the Loma Planetarium at MOAS. And in this edition, we're covering the dates of September 26th through October 2nd. We're going to start things off by talking about the opposition of Jupiter when it's closest to Earth in its orbit and when it's biggest and brightest in the sky. Then we're going to talk about the impact of a spacecraft hitting an asteroid, part of the DART mission from NASA, which is very exciting. I'll talk about what that entails. And then we're going to end with a farewell to the star Arcturus, a very bright star that is setting in the west right now. So let's get to it. Right at the beginning of this week, on Monday, September 26th, we have the opposition of Jupiter. And what's been nice is Jupiter has been rising higher and higher in the eastern part of the sky, along with Saturn. If you're looking towards the east right now in the evening after sunset, you'll find Saturn rising first because opposition of Saturn was last month in August, so it's had time to get a little higher in the evening. And now it's Jupiter's turn, a little bit below and to the left of Saturn towards the east right here. And it's great. Jupiter is so bright, being the largest planet in the solar system, a large gas giant, and closer to us than Saturn. Jupiter really shines and is usually the second brightest planet in the sky. And as I always say, planets look like stars that don't twinkle, so they usually stand out, especially one like Jupiter in the sky. Now again, what does opposition mean? Simply, it's when it's opposite of the sun in the sky, and that means we can see Jupiter all night long from sunset to sunrise. But regarding orbits in the solar system, this is when we are closest to Jupiter, which allows Jupiter to look bigger and brighter in our sky. And even though we're closest to Jupiter right now, it's still about 367 million miles away, and that's about 33 light minutes away. The light takes about 33 minutes to travel from Jupiter, the reflected light from the sun, of course, to get to us. And that allows it to be about negative 2.94 in magnitude. Remember, the lower the number of magnitude, the brighter an object is. So it really shines right now. And an opposition like this happens once a year. Jupiter takes 12 years to go around the sun one time, so it has a much slower orbit than we do. And since we have a speedier orbit, we go around the sun much quicker. And that means we pass by Jupiter once a year for opposition, allowing it to get big and bright in the sky. And of course, what I always like to say is if you have binoculars or a telescope, definitely take a look at Jupiter, especially through a telescope. It's so amazing. And last week's episode, we saw a transit of its largest moon, Ganymede, the shadow of that moon, cross Jupiter. And that's always fun to look out for. But just seeing Jupiter itself and what look like little stars around it, which are the Galilean moons, the largest moons around Jupiter, there are 4 of them. It's just really spectacular. We'll get a little closer here. And if you have a big enough telescope, those cloudy bands and maybe even the Great Red Spot can be visible. The Great Red Spot you can see about every 2 or 3 Earth days. Jupiter does spin very fast in its 10-hour rotational period, which means if you watch Jupiter over the course of a night, you'll see a lot of changes happening with the cloudy bands, but even the moons kind of orbiting around as well. So it's a really active system, which makes it a lot of fun to view yourselves. And still, what's nice is that there's a NASA spacecraft there at the moment. The Juno Spacecraft has been orbiting around Jupiter, giving us some spectacular images of its clouds, of its storms, and helping us understand internally what's going on and its magnetic field, and even the environment around it. It's even had a chance to look at the moon Ganymede, which is quite spectacular. So a wonderful planet to celebrate when it's closest to Earth in opposition, rising in the east right after sunset. And again, you can see it all night long for this time of the year. And what's also nice too is that the brightness of Jupiter will remain for quite some time, and we'll have it in the evening sky for a while as well, along with Saturn. So definitely take a look at that. Coming up soon. If you missed the exact opposition date on Monday, that's okay. It's still going to look pretty much the same all week long, and even the next few weeks. Locating planets at their brightest is always a real treat. Now, also happening on Monday, September 26th, is an amazing space flight event that's never been attempted before. And this is the impact of a spacecraft hitting an asteroid to see if it can be moved just a little bit. This is what's called the Double Asteroid Redirect Test, or the DART mission. This is a joint mission by NASA and the Johns Hopkins University Applied Physics Laboratory. And it's an amazing mission to see if we can alter the orbit of an asteroid in case one day we need to move an asteroid that may threaten Earth at some point. So this is important for the future of our safety when it comes to asteroid impacts that could potentially wreak havoc on our planet. And of course, we know that Earth and all the other celestial bodies in our solar system have endured numerous impacts from comets, asteroids, meteors over the history of the solar system. If you just look at the moon in our sky, the moon is covered in craters, and Earth would look the same, but we have a changing environment that has covered up many of those craters and sort of washed them or blown them away over time. And of course, we know very well that the dinosaurs went extinct because of a massive asteroid that hit the Earth about 65 million years ago. So this is an attempt to see if we can kind of change the orbit of a very small asteroid, and it's actually part of a binary asteroid system. This is a really interesting system, and we can actually find it in our sky in Stellarium. I actually have the time set to the very early morning, and there is an asteroid called Didimos. It's a fun name. It's a Greek name for twin because this is an asteroid which was discovered in 1996. It was discovered to have a moonlet going around this asteroid. So basically an asteroid with a moon system. And the moon was discovered in 2003 called Dimorphos. This asteroid is very tiny and very, very dim. You can't see it even through an amateur telescope, but it can be located in the sky. It's actually not too far from some winter constellations like Orion the Hunter here. This is the brightest star Sirius over here. Actually, right on this side of the sky right there is the planet Jupiter there. So there's Jupiter, as we just talked about. And this is kind of a rather dim area of the sky, but not far from these winter stars is the location of Didymos here. Now here in Space Engine, we can examine this binary asteroid system. And this is actually considered an Apollo asteroid and also a near-Earth asteroid as well. Now, the good thing is this asteroid does not pose a threat to us and to Earth. It doesn't really cross our orbit, but it's actually very close to us right now. Of course, you can see the sun here in the middle. There's Mercury, Venus, and then there's Earth right there, and there's the Didymos system there. So we're actually kind of nearing it. And we can zoom into this tiny double asteroid here. And there we have it. There's the Didymos system. So there's the larger of the two objects here. This is the original object discovered in 1996. It's about half a mile in diameter. And it was discovered in 2003 to have the small companion here, which is Dimorphos, which is only about 525 feet in diameter. So it's quite small. And Dimorphos is the target for this DART spacecraft, which was actually launched last year in November on a Falcon 9 rocket. It launched from California on about a 10-month journey to this small object here. And now that that spacecraft has reached this system, about 15 days prior to the impact, a CubeSat was released. It was an Italian CubeSat called LICIACube, which stands for Light Italian CubeSat for Imaging of Asteroids. So that little CubeSat has cameras on board and will image the impact as it happens, because the main DART spacecraft is the actual impactor that weighs about 1,200 pounds and will smash into Dimorphos at about 15,000 miles per hour just to nudge it a little bit. And that tiny little CubeSat will watch the impact happen so we can understand the process and the plume that's emitted from it. And then telescopes back on Earth will measure the change in the orbit. It's going to be a very slight change, but ever so much that they can see it has a tighter orbit or a faster orbit around Didymos. Now, there's no risk of the spacecraft pushing Dimorphos in an orbit that endangers the Earth, but it will slightly change its orbit. And even slight changes can have a big impact on the final trajectory of an object. So if you can find an asteroid that's about to hit Earth years down the line, and you have an opportunity to hit it just a little bit, a tiny change years before an impact makes a big difference once that asteroid gets close to Earth, potentially keeping it away from our planet, preventing us from becoming extinct like the dinosaurs, because the dinosaurs didn't have a space program. Luckily we do, and this is our opportunity to learn something from this process. So we'll see how this DART mission goes. This is very difficult. This is a very tiny little object, And the engineers and the scientists at the JHU, APL, and NASA have to hit a hole-in-one to get this just right. And I'm pretty confident they will, but it's still very, very challenging. So the exact time of impact is actually at 7:14 p.m. Eastern Daylight Time of the United States. And of course, you can adjust for your time zone. And there is a live feed from the DART mission webpage or from NASA that you can tune in and to watch the coverage about this and to watch the impact happen as well. So that's very exciting. We'll see how that goes. I'll just say go DART. And to wrap things up, if you're looking towards the west just after sunset at this time of the year, you can start to say farewell to the third brightest star in our sky and the brightest star in our northern hemisphere sky. And that, of course, is the star Arcturus. I talk about the star quite a bit. It's technically a spring star you can see all through the summer and into the early fall. You still have a little time to see this star a little bit above the western horizon, but it is getting a little more difficult to find. But it's a great star to talk about because it's what our sun will probably look like in billions of years. This star kind of started off like our sun, has run out of fuel in its core, and has been expanding and getting larger. It's turned into a red giant about 25 times bigger than the sun and almost 200 times brighter. So it's quite large and quite bright and fairly close to us at about 36 light years away. So it's kind of a neighbor for us in the star field around our planet. And this star is famously part of the constellation of Boötes, the herdsman right here. This is a fairly well-known spring constellation not far from the Big Dipper. And one thing I like to say about the Big Dipper's handle right here is that the handle arcs to Arcturus right there. So it's a great star to still find in the western part of the sky. You can start to say farewell to it until it rises again, especially in our evening sky next winter and spring. Hey, thanks for tuning in to another episode of our Sky Tonight program. If you happen to be at the Museum of Arts and Sciences, definitely check out what we got going on, especially our Lohmann Planetarium, where we're running shows every single day. If you want any more information about our programs and our show schedule, please check out our website online and tune into our various social media channels. We got some great things going on right now from all sorts of areas in our museum. So we'd love to see you tune in there, but hope to see you back here again. I'll say go for the DART mission. And of course, happy stargazing.